Hi everyone, I hope you're doing well. In this video I will show you how to use Gemini models to summarize a single YouTube video to extract specific structured outputs from a longer YouTube video, and we will use the model to create insights from analyzing multiple YouTube videos using async generation. To do so, let's start with installing necessary packages. And to use the newly installed packages, we need to run this cell to restart the kernel. You need to authenticate the environment by running this cell, and you need to set Google Cloud project information to create a client and use Gemini models. To do so, guys, you need to click on this link and you will be redirected to Vertex AI, and here you need to confirm the project and to enable the API. Once it's done, you need to add the project ID that you put here, and the project ID you find it on Vertex AI, like here. If you click on the list of projects, you will have the project and with its ID, and this is the ID that you need to copy paste in here. If you've never used Vertex AI, I have another video where I show you how to create an account on Vertex AI, where you will have a credit of $300 that you can use them to play with Gemini models and take advantage of all functionalities present on Vertex AI. So don't hesitate to watch the video, guys. I will put the link to the video in this video description, and I will put a link to this notebook as well in the video description. So once this is done, you need to import necessary libraries. Here are some configuration related to notebook options, and here is a very simple helper function where we pass the video URL and the function displays the video. Here are the models that we will use in this notebook, and here we have our first application. So if we call the helper function, here we have our video displayed that we will summarize, and here is how we summarize the video. So let's run this cell. So what we have here is the video summary prompt, where we ask the model to give a detailed summary of a video. We call the generate content method, to which we pass the model ID that we defined here, depending on which model we are using. In the contents, we pass the YouTube video URL and the video summary prompt that we defined here. And as a result, we have the summary of our video. This is amazing, guys, isn't it? In few lines, we can use Gemini models to have the summary of a full video. Let's see another application, which is extracting structured output from a YouTube video. In this case, we'll take a video that covers multiple topics, and we'll use again Gemini model to analyze this video. So here I'm using the short form of the video, but you can use the longer form as well. We display the video the same way we did for the other one. So here we are doing kind of the same thing that we did in the previous cell, but here we are providing more detailed prompt where we ask the model to provide a summary of the biggest product announcements that were made in the video, and we want the output to include the name, the product status, which can have the value of GA for generally available, preview, or coming soon. We ask for the keynote as well, and we ask the model to make sure to look through and listen to the whole video from start to finish to find the top product announcements. And you ask the model as well to only reference information in the video itself in its response, so that to avoid hallucination here. And what we are doing here to have a structured output is that we are providing the schema that we want the model to take into consideration to have a structured output. So here we are providing the schema of our JSON object, where we precise that we want to have the name of type string. The product states is going to be a string as well, and we want it to be a value among these values, which are GA, preview, and coming soon. And we want the third key of our JSON output to be the code from the presenter of type string as well. And here we need to define the generate content config, where we pass the video extraction response schema that we defined here. So it's going to be considered in the generation. And alongside this information, we provide also the temperature, max output tokens, and the response MIME type. Once all these objects are defined, we call the generate content method, where we pass the modal ID, so one of the modes that we choose. We pass the video extraction prompt that we defined here in the beginning. We pass the video URL, and this time we pass the config that we just defined here. So now the model has all information that we need. Once we run it, the answer will be generated. And here we have the output of our model. As you see, we have different products that have been mentioned in the video. So I leave you watching the video, you will see that all these have been mentioned. We have Gemini 1.5 Pro in the previous states, and we have the code from the presenter where the presenter talks about the Gemini 1.5 Pro. We have the same for this product, and the other products. When we have the product states, or we have any information that is present related to the product. Here we have for this product, we don't have the code from presenters. So here it's to be checked if really the information doesn't exist in the video or the model did not extract it. So this is amazing, guys, isn't it? Like, we have the information that we asked from the model, and we have it in the format that we asked the model to generate. And we have it in only a few lines of code. This is crazy, guys. Also, what we can do, we can take this model output and we convert it to a data frame. And here we have our data frame with the name of the product, its states, and the code of the presenter. Let's see another use case now, which is creating insights from analyzing multiple YouTube videos together now. Like, till now, we just used only one video to summarize it or to extract information from it. In this use case, we are using many videos together and we are creating insights from analyzing these videos. To do so, we will use yearly search videos, which are a total of 14 videos from 2010 to 2023, and each one has 2 to 3 minutes duration. First of all, let's take a look at our data. So here we have a data frame with years and links to videos created in each year. Now, our use case, let's say we are a sports agency and we want to see which athletes or teams appear most often in these videos. Instead of watching and manually counting athletes or teams, we can use Gemini multimodal capabilities to extract this information in a structured output. And here is, as we've seen with the other videos, we will start with creating our prompts. Here we have a system prompt which says you are a video analyst that carefully looks through all frames of provided videos, extracting out the pieces necessary to respond to user prompts. So this was the system prompt, which was kind of telling the model what role it will have and what it's supposed to do. And here in the extraction prompt, we are giving more details on what the model has to do. So here we are asking the model to extract sports athletes or teams which are mentioned or shown in the video, to look through each frame carefully and respond with a complete list that includes the athlete or team's name. And we are even precising that it should be one row per athlete or team. We want the model to mention whether it's an athlete or a team. We wanted to mention the sport that they play and the time step in the video at which they appear. And we even precising the format of the timestamp. Once our prompts are defined, and prompts, guys, are very important and they should be well crafted because the model will base itself on them to generate the answer. Once they are defined, here again we are defining the schema, but in this case we want our output object to contain 4 keys. The first one is the name of the athlete or the team, whether it's an athlete or a team. We even precise this in a list. We want the sport that they play and the video timestamp where they appear. The same way we've done for the previous video, we pass this in the generate content config, and we precise as well the other parameters. But another difference here compared to the previous videos is that we are calling the generate content method, but in async way. So this way we send all the requests and we wait for all answers to come back. So this is the async way, which is far more efficient than sending them one by one. And here is how we do it. We use try except blocks. We use our generate content method, but in async mode in this time. We precise the module that we want to use. We provide the prompt, the link to the video, and the generation config that we already defined. And here we are using a retry mechanism defined as a decorator, and we even define how many attempts we want to try. Once our function is defined, we parse all the video's links and we pass each link to the function alongside with the extraction prompt. Once our function is defined, here we create the async tasks, which will be the function to which we pass each link of the videos and the extraction prompt. We wait for all the results. So once we have the results, we can manipulate them a little bit to have a table like this one, where we have the year, the name of the team or the athlete, a column to tell us if it's a team or an athlete, the sport that is played in the video, and the timestamp. So exactly what you asked for. This is wonderful, guys, isn't it? And here in this function, we only do some manipulation of the output. So let's parse it very quickly. We make a copy of the YouTube links. We parse the extraction responses. So here are the outputs of the model. We create another column in this data frame that we call Gemini response, to which we assign the list of responses. So it's going to be a new column in the data frame. After that, we are creating another column of this same data frame, to which we assign the result of this function that we define here applied on this data frame. So these are details, guys, to organize a little bit the data that we have, but just I wanted to go through the code to make it more clear, hopefully. And what we are doing in this function is that we are taking each row of the data frame, more specifically the rows from year and Gemini response columns of this data frame. We read the response from the Gemini response. We create a data frame from this response and we add the year to this data frame. We apply this on all rows, and as a result, it's going to be affected to a new column called extract result df. Once we have this, we concat the list of the data frames and we keep only these columns. So this is why we have a data frame with only these columns. And what we can do as well is grouping information and doing sort of aggregation to have this result. So here we are grouping names of athletes or teams, and we are counting the number of years where these athletes or teams appeared. As you see here, we have the names that we transformed in capital letters. We have, if it's athlete or team, the sport that they played, and the number of years that they appeared in the videos. And this can be done in these few lines of code. So here we are taking the resulting data frame from the previous cell. We are assigning, means creating new columns that we are calling name, athlete or team here. So here we are actually overwriting the existing columns, but here our new columns will be in uppercase that we see here, and the athlete or team column will be in lowercase. We are doing this on purpose. It's kind of normalization so that we'll have the same strings so that we wouldn't have any duplicate when we group by these columns. After that, we aggregate on sport and we count the different number of years this way. After that, we keep only those which appear multiple times, and we sort values in descending order for the number of years. once this is run, we will have this data frame the way we wanted it to be. This is it, guys, for today. I hope you liked the video. I find it amazing what we can do nowadays with these kind of multimodal models. So like today, to summarize, we used these kind of models to summarize a YouTube video. We used them to extract information and returned in a structured format, and we used them to process many videos at the same time, and we have the analysis that we ask for in the prompts. I will put the link to this notebook in the video description. I will put the link to the video where I show how to create an account on Vertex AI to use Gemini models. Don't hesitate, guys, if you have any question on any concept about which I talked so far, and see you next time.